So hello YouTube, and we are doing the installation of the basic system software still. So this is chapter 8. And we're starting at this video with 8.50, which is libffi. So what we need to do first, because I've got to do it before I exited the other video, we need to follow the installation instructions, which are here in this tab. So important for each package, you need to use tar to extract package, change to the directory created when the package was extracted, follow the instructions for building the package, change back to the source directory when the build is complete, and delete the extracted source directory unless instructed otherwise. So we need to rm minus rf elf utils. Done. Then we do tar xf lib ffi, and then we cd into lib ffi. Now what we're going to do is we just follow the instructions. So immediately there's a note here that says, just rearrange my desk a little bit, stuff's in the way. It says here, like GMP, libffi builds with optimizations specific to the processor in use. If building for another system, change the value of the with GCC arch parameter in the following command to an architecture name fully implemented by the CPU on that system. If this is not done, all applications that link to libffi will trigger illegal operation errors. So basically they won't work. I'm only ever going to use this on 64-bit x86, which is pretty much most PC processors at this point. So we're just going to do the regular configure, so it shouldn't make any difference. That one. And the meaning of the configure option, it kind of explains that there. Ensure GCC optimizes for the current system. If this is not specified, the system is guessed and the code generated may not be correct. If the generated code will be copied from the native system to a less capable system, use the less capable system as parameter. For details about alternative system types, see the x86 options in the GCC manual. And then we do the compile the package. Make, then make check. So it's going to take probably a minute or two. Didn't actually read out what the package did. So the libffi library provides a portable high-level programming interface to various calling conventions. This allows a program to call any function specified by call interface description at runtime. FFI stands for Foreign Function Interface. And FFI allows a program written in one language to call a program written in another language. So this is marshalling, I think. Specifically, a libffi can provide a bridge between interpreter like Python and Perl and shared library routines written in C or C++. And you'll see this a lot. So I believe there's there's something called Swig. Well, this is doing its bit. It's called Swig. Binding. So I wonder. So Swig. So what is Swig? Swig is a software tool that connects programs written in C and C++ variety of high-level programming languages. Swig is used for different types of target languages, including common scripting languages such as JavaScript, Perl, PHP, Python, TCL, and Ruby. So this sounds like it's something similar, like this automates Whoops, that's something not relevant from the last video. This looks like they're related. So Swig related to FFI. I'm just curious about this. Oh, look. FFI Swig generator is a Ruby FFI wrapper code generator that produces Ruby FFI glue code, passes C header files through Swig. Okay. So they're related things, but I don't think they're this. I don't think they're the same thing. I know from doing some coding with SDL, Swig is used a lot of the time to generate bindings for between SDL and Java, or SDL and C#. And that's typically like it's looks like it's somewhat related, but it's not one of those things that my day-to-day job is doing JavaScript and Go, C# and similar languages, much higher level. So I usually don't ever have to go this deep when programming. So I'm wondering whether this is a lot of concepts are reused from C, C++, and lower level languages once you get the like higher level languages. So after I've waffled a bit about Swig and this, and probably being pretty inaccurate about what I'm saying, that looks like it's worked correctly. Expected number of passes 2436, and there doesn't seem to be any. I think we're good. I think we're good on that. Looks good. So and we've done a make install. So we're done. We're done with this package. So libffi is installed. Now we need to build Python. And this is looks to be the big one. I did this book. I started this book a little while ago, and I think they might have updated the book. There might be 12.4 out, but we'll just carry on using version 12.3. I'll have to check actually. It's not particularly important. I don't think be any major changes between minor versions of the book. So, as always, we follow the procedure. So we cd out of here, and we rm rf libffi, boom, and then we tar xf Python, and we cd Python. Now, I'm sure most people are familiar with what Python is. So this is the Python 3 package. Well, let's just read it. The Python 3 package contains the Python development environment. It is useful for object-oriented programming, writing scripts, prototyping large programs, and developing entire applications. Python is an interpreted computer language. And one of the reasons why Python is so popular is because it is easy and it is actually reasonably decent at a lot of things. So if you actually learn Python and get really decent at it, you can basically program quite a lot of bits and pieces with it. It's very good these days. Back in the 2 point whatever branches, it wasn't so good, but now it's really, really good. Right, the approximate build time is a little bit longer than the other things, but it doesn't seem too excessive. So we're in here. So it says installation of Python 3. We did a configure step. So let's have a look at the configure options. It says with system expat, this switch enables linking against the system version of expat, which is, we compiled that in the previous video. Enable optimizations. Well, kind of says what it does. I'm not going to bother reading that out. Oh, Oh, I extracted the docs by the looks of it. Am I missing another package? So I should have checked that script more carefully. But there's Python and Python docs. Yeah, this did not download correctly. So let's copy this address. Let's clear this. And all I'm doing is wgetting this. I don't have wget in this chroot, so I have to use this as just regular. By the way, if you'll, I did this in the last video. What I'm doing is it's a bit of a hack. Debian has all the tooling like wget, curl, and all the good command line tooling. We're still building it in here, so we don't have it. So we didn't get Python last time, so I probably don't need to do this, but I'm just going to do it anyway. I don't need to do chown args. Bloody file, I can't type. And it's Python. No. Did I just download the docs again? Oh, it's capital P for Python. So delete that extra file because we don't need it. It's capital. It's very annoying it did that. That is with capital P. So let's try again. It's tar xf capital P for Python. There we go. And then we cd in Python. Got the 3.13.2. Yeah, that's the correct version. And then we do the configure step. So if we go back to here, just copy this in again. That's better. Right, there's the configure step done. And then we're going to do make. I imagine this might take a little while. Right, so that's compiled, and then we run the tests. So it says here, some tests are known to occasionally hang indefinitely. So to test the results, run the test suite, but set a 2-minute timeout for each test case. Seems fair. Imagine that might take a little while to run. I like how it says some tests are flaky, so the test suite will automatically rerun failed tests. Well, something wrong with the testing then. That's a big smell for me. That is. Why would that happen? Right, and then it says here, if a test failed, but well, let's read that again because I stumbled over myself. If a test failed, but then passed when rerun, it should be considered as passed. One test SSL is known to fail in the chroot environment. Okay, so we'll just let that go, and this looks all very. It's very suspect. This is. I can't believe that something as major as Python, this can be the case. There must be a particular reason for that. Right, and then we're done with this. So that was 499 tests okay. 29 script skip. 10 slowest tests. Result success. So that worked. I think we're good. Now we install the package. So this is use procedure make install. And this will just copy bits and pieces. Okay. Right, so what it's saying here, I won't read out the whole thing, is that this warning about running pip as root, pip freeze run as root while we're doing this. Yeah, we use the pip free command to install Python free programs and modules for all users as root in several places in this book. Yeah, so this is like, this warning is not relevant in this circumstance. Yeah, so the main reason for the recommendation is to avoid conflicts with systems package manager, G package, for example. Yeah, so when you're doing any Python dev, what you'll find is that typically you have like system Python packages, and they are managed by the package manager, and then you'll have like user packages, and then you can have packages in a virtual env. So I install a lot of packages as a user. So for some of them I can't mention because they're on YouTube, because we're on YouTube. However, there's so for example Ansible, I think I install as a user, and then just put the path into where it puts the bin files. I have that in one of my Debian videos. I might actually link that video via a card. So we'll actually do that. And then and that's what this is warning of. Yeah. Also, pip3 will check for a new version of itself whenever run. Since the main name resolution is not yet configured in LFS root environment, pip3 cannot check the new version itself and produce a warning. Okay. After we boot the LFS system and set up a network connection, a different warning will be issued telling the user to update pip3 from a pre-built wheel on PyPy whenever a new version is available. But LFS considers pip3 to be part of Python 3, so it should not be updated separately. I actually agree with that. I don't like how it wants to update itself. I want, like, if I've downloaded Python, if I've installed Python via apt or Pacman or whatever tooling I'm using, now I install pip, I want those at whatever versions that the package manager of the distro is maintaining, because then it doesn't mess with the rest of the system with my package manager. It's a very odd choice. I'm not sure why they do that. Also, an update from pre-built wheel would deviate from our objective to build a Linux system from source code. Yeah. So warning about a new version of pip3 should be ignored as well. If you wish, you can suppress all these warnings by running the follow command, creates a configuration file. Okay, we are actually going to do that now. Right, so this actually looks all very important, so we should read all of this. Done. Now, it has an important note here. In LFS and BLFS, we normally build and install Python modules with the pip3 command. Please be sure that the pip3 install commands in both books are run as the root user. Less is for a Python virtual environment. Running pip3 install as a non root user may seem to work, but it will cause the installed module to be inaccessible by other users. So, as I said previously, it will go and install into the home directory of that user, and it'll be .local/bin or something along those lines. I forget the exact path. I just usually just bang it into my bash RC and just forget about it. Pip3 install will not be pip3 install will not be reinstalled and already installed. Oh, this is weird how this is. Pip3 install will not reinstall an already installed module automatically. That's a mouthful. When using pip3 install command to upgrade a module, for example, from Meson 0.61.3 to Meson whatever, the next version, insert the option upgrade into the command line. If it's really necessary to downgrade a module or reinstall the same version for some reason, insert force installed no depths into the command line. Okay. That is it's going to be. Now what I'm going to do, I'm going to open another tab. Do that. I'm going to put that all the way along here because I bet we'll need it at some point. That's it. Close that swig one, and we'll go back in Python. Let's go back to the thing. And then it says, if desired, install the pre-format documentation. I always love documentation, so we will do that. Yep, and there's some tar. Blah, 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 blah. Oh yeah, that's a Python docs HTML that I tried extracting earlier by mistake. So it's got some options here. Right, ensure the installed files have the correct ownership and permissions. Without these options, tar will install the package files with the upstream creators values. Okay, and there's oh look, there's Python 2 to 3 converter idle. Pip3, PyDoc, Python 3. I don't think will idle be installed. I don't think so. Okay, it is. So for this script to run, you must have installed TK before Python, so that the TKing the Python module is built. We won't worry about that. I don't actually ever use idle. Now, as always, we're going to CD back before we go on to the next package. rm minus rf Python. And then we click next and Flit-Core 3.11.0. Flit-Core is a distribution building part. Is the distribution building parts of Flit. Doesn't really tell me what it is. But this does. A packaging tool for simple Python modules. Okay. I've not heard of this actually. So this is why we're doing this. Is a learning experience for me. Hopefully other people might get something out of this, or 5 people that watch these videos. So look, this is what you were saying in the previous when we was installing Python. We're going to be doing these pip3 wheel blah blah blah. So it's installation of Flit-Core. So build a package. Okay, let's go. Oh, we have to. I'm being an idiot. XF. There we go. And then we're in there. So then we issue this. Pit free wheel. -W dist. No cache. Yeah, so wheel builds the wheel archive. Okay. Yeah, so W instructs pip to put the created wheel into the dist directory. So that's just an output directory. No cache there prevents pip from copying the created wheel into the root.cache pip directory. So that, yeah, so pip has a cache. And this is just disabling that. And then on the next line, which I haven't run yet, so let's just run this. Done. The command installs a package, so no build isolation, no depths, and no index. These options prevent fetching files from the online package repository PyPy. I think I'm not sure how I feel about PyPy because you can actually get dodgy packages from PyPy, which have malware on them. Same with npm or almost even Go with some of the repos using the Go. I think it's Go install. If packages are installed in the correct order, pip won't need to fetch any files in the first place. These options add some safety in case of user error. Okay. Find links dist instructs pip to search the wheel archives in the dist directory. So it just tells, it's telling pip where to look for a particular thing. So it's built. So if we quickly go in here, there'll be a dist directory. And then that is our wheel package. Now, I have built these before, but not with Flit, with, I think, Setuptools. However, it was a while ago, and I've forgotten the what you need to do. Setuptools, you basically set up you have a TOML file, and then there's set commands. This is what we're doing here seems a lot more straightforward. So maybe I need to look into this because I did Setuptools before with some of my with some tooling that I made for friend, and it took me like half a day to figure it all out because I had to go through the learning process. I hadn't done it before, and I haven't done it since either, but I am aware of it. So we built the oh yeah, we need to install. So all this does is install this package essentially. There we go. And the reason we needed Python installed before is because this is all Python code. So if we actually ls in here, and then we did cat like bootstrap install, we do to cd into, yeah, these are all Python here, and there's the wheel.py. We can have a look in there. That's the argument path. This is, I think this is what installs the wheel, maybe. Building wheel from, okay. Anyway, it's massively off topic. So that looks like that's built correctly. And what we need to do is we delete the directory, and then we do wheel. And this is another Python program. So what we need to do is we clear the screen first. XF wheel. Yeah, so it's wheel 0.45. And what does wheel do? Wheel is Python library that is the reference implementation of the Python wheel package standard. Okay. So that's what we do. And oh, I have not DD'd into there. Yep. And this is pretty much the same as before. So if you remember, there'll be a wheel in here. And then, oh, right. So that's how it builds the wheel for Flit. It's because it's got its own implementation of the wheel package. Okay. Very, that's interesting. RF wheel. That was nice and easy. So we're now going to build Setuptools. I have used this before. And now this is getting into small stuff that I actually know what it is. So I'll be sounding less confused, hopefully. So again, clear screen, car XF, and it'll be Setuptools, I'm guessing. Yeah. And Setuptools is used to download, build, install, and upgrade and uninstall Python packages. So this is kind of what was used before pip, I think, or maybe it's used in conjunction with pip. I'm not like a full-time Python developer, not like a super expert. I have done a fair bit of Python programming though, but I always use a virtual env. So I always use a virtual env with pip and requirements.txt. That's how I do it. Other people use things like poetry, etc. I've not felt the need to use those. So, and usually the people like to layer up tooling, and it's a lot of the time it isn't necessary if you keep your source, you keep your dependency list low, and your program sources clean. You don't have to do a lot of this, but people just like to layer junk on, which is unfortunate. One of the reasons I'm learning to do this. Right, that's installed Setuptools, so we CD out of it. And again, we rm-rf Setuptools, clear screen, and we're going to build Ninja. Ninja, I already know what Ninja is. Ninja is a small build system with a focus on speed. Now, Ninja is kind of a bit like Make, I think. Right, so install a Ninja. When run, Ninja normally utilizes the greatest number of processors in parallel. By default, this is the number of cores on the system plus 2. Okay, that's a bit odd. This may overheat the CPU or make the system run out of memory. When Ninja is invoked from the command line, passing the JN parameter will limit the number of parallel processes. Some packages embed the execution of Ninja and do not pass the J parameter to it. Using the optional procedure below allows the user to limit the number of parallel processes via environment variable. Ninja job. Sounds like a bad recruitment website. Ninja jobs. For example, setting export Ninja jobs 4 will limit Ninja to 4 parallel processes. Well, I've got 4 cores in this system. That's exactly what we want to do. So we're going to export the Ninja jobs. If desired, make Ninja recognize the environment variable Ninja jobs by running the stream editor. Yep. Let's do that. That sounds like a good idea, actually. Oh, because I have not undhard it. I didn't follow the procedure. Oh, it needs to be XF. CD Ninja. What am I doing? That's what I need to run. Right. And build Ninja with, so that's why we need to install Python first, because Python needs Ninja to build. Sorry, Ninja needs Python to build, I should say. Meaning the build options bootstrap, the parameter forces Ninja to rebuild itself for the current system. Verbose, this parameter makes the configure.py show the progress building Ninja. Okay. So that sounds reasonable. Right, so, and it's saying here that you can't run a test yet because they require CMake, which is, looks like it's in the BLFS. So CMake is its own like build programming language tooling. I've used it a fair bit when doing C++ stuff. But the basic function of this package is already tested by rebuilding itself with the bootstrap option anyway. Okay, so let's just run this. Oh, we need the Python on the front. Oh, god damn it. How long is this going to go? Oh, not long at all. Right, there we go. And then we just need to do the installation, which is running these install commands, which all the install does is cd and set the file mode bits, essentially. So that looks like that's done. So we follow the procedure, we cd out, we rm -rf ninja. And next we go to Meson. So Meson is an open source build system designed to be both extremely fast and as user friendly as possible. I've heard the opposite from people complaining about it, but developers like to complain about things that they don't understand, just say it's rubbish. So it might be very good, and those people didn't understand it. So again, this is, we're just building the wheel. There we go. And it says test suite requires some packages outside the scope of LFS. Okay. That's fair enough. And then we do the pip install, and then it looks like it copies the shell completion. Okay. So let's just run all of this. Meaning of the install parameters puts the created wheels in a dist directory. Yeah, we already covered that. Find links dist, installs wheels from the dist directory. I'm sure we covered this in the previous chapter. So that looked like it. Yeah, that's all ran properly. Let's just press down, couldn't I? Yeah, that's all run properly. And then, sorry, I'll get some water in a minute, I think. Right, so we rm off Meson. So these are all Python based. So this is why we need Python first. Okay. The Kmod package contains libraries and utilities for loading kernel modules. Okay. And it needs Ninja. That's why we needed to install Ninja, Python to install Ninja, and then we can install Kmod. Okay, this makes sense. So we tar xf Kmod, and what we're going to do is run that. Oh, I haven't. I'm an idiot. Right, so I would have done anything anyway. Yeah, this needs Meson to do the configure. Okay. So we need Meson and Ninja. So that's what we needed to build those. And then we need to go into the Kmod sources. And then I'll run this again. So I'm just going to paste this again. What does it say? Right, so the nose here is looking for particular packages. Okay. So it's trying to work out what's, so when you do configure, it tries to configure it for your system. And what it can't find CMake because we haven't built it. Batch completion probably because we don't have the dependency, and we don't have fish, which is another type of shell if you're unfamiliar. And then we do Ninja, and this will build it. And Ninja is very fast because it uses all your cores, and it can also, I think it can also cache builds, so it's a lot faster to make. The test suite of this package requires raw kernels headers, not the sanitized kernel headers installed earlier, which are beyond the scope of LFS. Okay, so we don't have that. Now install the package, so Ninja install. Done. So if we just go in here, is there a Ninja file? Does it uses a file called Ninja or something? Yeah, build.ninja. So if you go cat build.ninja, this is your build script. Build script. So when it does Ninja install, it will run install. Build all. Yeah, there we go. Anyway, that's what's happening underneath. We cd out that, cd out that. Oh, cd dot dot, and we've got that mapped. Right. And now we're going to do Coreutils, and I've got a feeling, let's have a look at Coreutils. These all seem to be right. So let's clear the screen. Part XF Coreutils. Oh, got part XF. Then we cd into Coreutils, and then so let's say, I think we've gone over Coreutils before, but let's go over it again because it was several videos ago. The Coreutils package contains the basic utility programs needed by every operating system. Okay. POSIX requires that programs from Coreutils recognize character boundaries correctly, even in multi-byte locales. The following patch fixes this non-compliance and other internationalization-related bugs. Okay, so we do patch. Done. Now prepare Coreutils for compilation. Okay. That's not right. Let's try this again. Right, so, and this is why we need autoconf and automake by the looks of it, is because we need to install those packages because these are required for Coreutils. So let's just do that. I didn't read out these command line options. So auto reconf -fb, the patch for internationalization has modified the build system, so the configuration files must be regenerated. Normally we would use the I option to update the standard auxiliary files, but for this package it does not work because configure.ac specified an old get text version. Okay. And automake.af, the automake auxiliary files were not updated by auto reconf due to the missing I option. This command updates them to prevent build failure. Force unsafe configure. equals 1. The environment variable allows the package to be built by the root user. Okay. Enable no install program. Kill uptime. The purpose of this switch is to prevent Coreutils from installing programs that will be installed by other packages. Okay. And we do make. Right. Skip down to install the package if not run and test suite. After we will run it. And this will probably be the last thing we'll do today. Now the test suite is ready to be run. First, run the tests that are meant to be run as a user root. Okay. Do that. That looks okay. So no failures. Right, so what it's going to be doing is, I'm not going to read all this out. Okay. What we do is we add this user and then we change the ownership to tester because basically it needs to be run under a different account. Now run a test using dev null for the standard input, or 2 tests may be broken if building LFS in a graphical terminal or session in SSH or the GNU screen because the standard input is connected to a PTY from the host distro and the device node for such a PTY cannot be accessed from the LFS root environment. So we're probably going to get a some failures here. Right, there we go. They all worked. Oh, it says 2 tests may be broken, but they're not, so that's good. And then we remove temporary group. And then move the programs to the location specified by the FHS. So we just run that, just move some files. Oh, haven't done make install yet. Idiot. That's why you can't move the files, because they're not there. And then we run this block again. There we go. That worked. So I've got about 10 minutes left on the hour. So I thought this was going to take longer. So we're going to do whatever check is. I don't know what check is. Let's have a look. First, we must go back. RM minus RF Coreutils 9.6. And then we're going to do tar xf check. There we go. Check is a unit testing framework for C. Oh, that's cool. I didn't know these existed. I knew of Catch 2 and the Google one. And C test is the other one, I think. I didn't know about this one. It's interesting. Well, it's interesting to me. And so this is the user configure options, and it disables static linking, I guess. There we go. And then make check. All right. So that looks like we've got 9 pass, no failures. That's good. And then we do the make install. And next we're going to do Diffutils. So this is same procedure as always. So we cd back firefighter check and tar xf Diffutils. I'm going to remove this directory to keep everything clean. That was there because I ran that command at the wrong time and it created a disk directory. Let's see if there's any other bits and pieces in there. No, we're good. We're good. So I need to do tar xf Diffutils cd to Diffutils, and then we do the configure. Oh, there we go. So we just run make. That's pretty quick, and then make check. This will do a load of bits and pieces. And we've got no failures, which is good. And then we do make install. Done. And we'll do Gawk because this is an easy one. We did this on when we was doing the temporary system. So Diffutils. So as per every time, delete the directory, and then we tar xf cd into that directory, and then it's a little bit different. First, ensure some unneeded files are not installed. So it just looks like removes the extras. Then configure awk for compilation. Let's do that. And we do make. And now we run the tests. So this is pretty much goes to change the ownership of the files to tester, and then it will basically run the tests as a user. All tests pass. That's good. Then install the package. So there was an old previously there was a version of Gawk for the temporary system. That version is going to get deleted by the looks of it, and then we do make install. Yeah, that's in the temporary system, I think. Is it the temporary system 6.9? Yeah, cross-compiling temporary tools, yeah. Well, I'll say temporary system, temporary tools. The installation process already created awk as symlink to Gawk. Create its man page symlink as well. Okay. If desired, install the documentation. I always follow the documentation, so I'm going to run that. And I'm just going to go up and see how much we got to do. Oh, we're almost getting there. So if we go back, I'm going to do one more. That's the Findutils. Is this looks fairly straightforward. So if we cd out this and rm minus rf Gawk, and then this is Findutils package. It's a package that contains programs to find files. Yeah, it also supplies the Xargs programs. We did go through this in the previous video because these tools are, I think these are used in the temporary system. When you create the temporary tools, so I won't read it all out again because there's no point. So the installation of Findutils. So prepare Findutils for compilation. So first we have to untar it. And then we cd into there. And then we run the configure. And while the configure is running, we'll look at the configure options. So the meaning of the configure options, there's a new one here. So there's a local state dir. This option moves the locate database to var lib locate, which is the FHS compliant location. Okay. And then we do make. That's done. And now it's basically the same as before. So you change the ownership of the files to tester and then run the tests. I'm guessing that it's to protect the rest of the system. Right. So there was no failures. There was a couple of skip tests. That's pretty standard by the looks of it. Then we do make install. And we're done with Findutils. So for this video, we're going to stop there. And we go back to here. All of this was really straightforward compared to some of the other bits of this book. To be honest, it's not too difficult, this book. It is a very repetitive, very mechanical. And then we've got, I think we should be able to do those. We'll just go through all the way till the end there, and that'll be basically everything. And then there'll be a cleanup, I'm guessing. Yeah, stripping cleanup. So we'll get to sys v init stuff. So it's this system 5 system. So I don't believe there's going to be any system D. So system D haters will be happy. And so anyway, that's it for this video. Hopefully see you in the next video, and bye-bye.